equals negative b plus or minus square. Oh, sorry everyone. Just singing a little bit. Okay, let's move on and stop the nonsense. We're going to talk about the discriminant today. Oh, I like the red. That's nice. The discriminant. So this is very much related to the quadratic formula, which I was singing to myself as I often do. So let's just write that over here, and I'll try not to sing this time. It is truly hard not to sing x equals negative b. But I'm hoping you recognize this. This is what we did last time. Okay, that's one way you can solve a quadratic equation, is to put the quadratic equation, make sure it's in this form, ax squared plus bx plus c equals 0, which is general form, and then plug the a value, the b value, the c value into the quadratic formula and solve, and you've got your roots or your solutions. Okay, so let's do that, and I'll explain why. You might be, well, we've already done the quadratic formula, why are we doing it again? But let's just quickly solve these four here. So in this first one, x equals negative b, so that would be negative 6, or 6. X equals 6 plus or minus the square root of b squared, 6 squared, that's 36, minus 4 times 5 times 8. I guess 4 times 5 times negative 8, that's pretty important to have the negative 8, all divided by 2 times 5. I'm just starting to think this is going to take too long to do this. So you get 6 plus or minus the square root of 36 plus, because minus 20, 160 over 10. So you get 6 plus or minus the square root of 196 over 10, which is the same as, you can take the square root of 196, it's 14. So you get 6 or plus or minus 14 all over 10. Which is, there's two answers, 1 6 plus 14 over 10 and 1 6 minus 14 over 10. So 6 plus 14 over 10 is 20 over 10, which is 2, and 6 minus 14 is negative 8 over 10, which is the same as negative 4 over 5. So here's our two answers, 2 and negative 4 over 5. Okay, let's do the next one. X equals negative b, so that'd be 8, plus or minus the square root of b squared, so that'd be 64, right? Negative 8 squared, minus 4 times 1 times 16 is 64, divided by 2 times 1 is 2. You might want to just do these on your own, stop the video and then check it. Anyway, you get x plus or minus the square root of 0 over 2, which is just 8 over 2, right? Plus or minus, square root of 0 is 0, so 8 plus or minus 0 is still just 8. You get 4. This is your answer for this one. Okay, the next one, trying to do these quickly. X equals negative b, so it's negative 4 or positive 4, plus or minus the square root of 4 squared, 16, minus 4 times 4 is 16 times negative 5 is negative 80, all over 2a, so that's 8. So x equals 4 plus or minus the square root of 96 over 8. And then we could put that in lowest terms. Whoops, x equals 4 plus or minus, 96. I'll do this over here. That's 2 times 48 and 2 times 24 and 2 times 12 and 2 times 6 and 2 times 3. So there's a pair and there's a pair. So 2 times 2 is 4 root 6. I hope that makes sense. Divided by 8, and then you can divide all three of those numbers, the 4, and the 8, by 4. So you end up with x equals 1 plus or minus root 6 divided by 2. That's our answer in this case. Let's highlight that one. We have one more to go. X equals, it must be kind of boring to watch, isn't it? X equals negative b, which is 5, plus or minus the square root of b squared, which is 25, minus 4 times 2 is 8, times 6 is 48, all over 2a. 2 times 2 is 4. So you get x equals 5 plus or minus the square root of negative 23, all over 4. And hopefully at this point you can see square root of negative 23, no good. So our answer here, you can't take the square root of a negative number, so no solution for this one. Okay, why am I doing this? What's the point of all this? Well, what I'm interested in is what if I wasn't interested in the actual roots? Like we found the roots here. The roots are 2 and negative 4 over 5. The root here is 4. The root here is 1 plus or minus root 6 over 2. The root here is no solution. What if I wasn't interested in the actual roots? I was only interested in the number of roots. How much of the quadratic formula, this right here, how much would I actually have to concern myself with? And I'm hoping what you see is I wouldn't need to do all this work I already did. If I wanted to know how many roots there were, I could just look at part of the quadratic formula. I could just look at this piece right there, b squared minus 4ac. And that right there is called the discriminant. And we can use that to figure out how many roots there are. We say to figure out the nature of the roots. So for example, let's go back and look at this again. In this first case here, the discriminant, the b squared minus 4ac amount, was 196. And we ended up with 2 roots. Let's look at the one down here. Here we ended up with the discriminant of 96, and again we got 2 roots. This is actually 2 roots, isn't it? It's 1 plus root 6 over 2 and 1 minus root 2 over 2. So, okay, so, what's the best way to do this? So here we got 2 roots when we had a discriminant of 196, and here we got 2 roots when we had a discriminant of 96. How about this one up here? Well, here the discriminant ended up being 0. That's a 0, believe it or not. And we ended up with how many roots? We ended up with just 1 root. And in the bottom one, we had a discriminant of negative 23, and we ended up with no roots. So hopefully you see the idea here. When you take a look at the discriminant, the b squared minus 4ac, if the discriminant's less than 0, you get no roots. How come? Because you can't take the square root of a negative number. If the discriminant is 0, you get 1 root. How come? Because the plus minus part is what makes 2 roots, and if it's just 0, it doesn't make any difference, right? You're left with the b value in front, the negative b value, I guess, and the 2a in the bottom. So you end up with 1 root. And if you have a positive number for the discriminant, you get 2 roots. Now, why did I show both of these? Why did I bother with 2 of them? What's different about these two? Because in the top case here, you ended up with a perfect square in here. This is a perfect square. 196 is a perfect square. So what you ended up with are 2 roots, and they are rational. So we could say 2 rational roots. And we could have factored. This is the only one we could have factored out of all these. Right? If you go back up there and look, we would have been looking for 2 numbers that multiply to 40 and subtract to 6, and those numbers do exist, 10 and 4. Sorry, 10 and 4. So we could have factored. This bottom one here, we ended up with 96. This is not a perfect square. Not a perfect square. And we could not have factored. No factoring was possible here. And you end up, so because it's not a perfect square, you don't end up with rational roots like you did here. You end up with 2 irrational roots. Oh, and if you want to be really, really precise about this, we should put the word real in all these. So we should say 1 real root and no real roots, and 2 real rational roots, and like that. There's even more I wanted to show you about this. I don't know if I should or not. This is really taking a long time. If we take a look at the associated quadratic function for this, so instead of looking at, what is that, 5x squared minus 6x minus 8 equals 0, if we look at y equals 5x squared minus 6x minus 8, we found with the equation we got 2 real roots. Do you remember how to relate that? Here it is here. Here's the equation. Or here's the function. Why do we have 2 real roots? Because we have one x-intercept here and we have a second x-intercept here. And look where the x-intercepts are. 2, 0, and negative 0.8. 2 and negative 0.8. And let's take a look at what our answers were for this. 2 and negative 4 over 5, which is the same as negative 0.8. So it works. Okay, let's look at this one. X squared minus 8x plus 16. So here's the 8x, x squared minus 8x plus 16 looks like this. And there's the only one x-intercept, and the x-intercept obviously is 4, and that's exactly what we got as our answer for that one, is 4. If we take a look at 4x squared minus 4x minus 5, that is this one. And you can see again there's two x-intercepts, but there's no, it doesn't go exactly through something. I mean, I know it goes through somewhere, but this is not something I want to talk about today, but it's an irrational number. You can't express it as a fraction. Okay, and the last one, 2x squared minus 5x plus 6. Since we got no solutions, you probably aren't surprised, it doesn't have any x-intercepts at all. Alright, we talked about that before, so hopefully that makes some sense. Oh, okay, let's write down exactly what we want to say about the discriminant, and let's get going here. This is taking way too long. Okay, so the discriminant is b squared minus 4ac. That's the discriminant. And it determines the nature of the roots. The nature of the roots, like what kind of roots do we have? So if b squared minus 4ac is bigger than 0, in other words, if it's positive, there are two real roots, or two real solutions. Okay, if b squared minus 4ac is equal to 0, there is one real solution, or one real root. And if b squared minus 4ac is less than 0, in other words it's negative, there are no real roots. It's basically what you need to know today. Okay, let's try a couple questions quickly. Without solving, determine whether the equation has 1, 2, or no real roots. So we could do the entire quadratic formula, but if we just want to know how many there are, we can just use b squared minus 4ac. So let's do that. What's b? Negative 8. So we have negative 8 squared minus 4 times a, which is 5, times c, which is 6. And that gives us 64 minus 4 times 5 is 20, times 6 is 120. It doesn't even matter what the answer is so much, just whether it's 0, positive, or negative. And 64 and minus 120 is definitely negative. Something like negative 56 or something like that. So how many roots are there? No real roots. It's less than 0, so there's no real roots. If you were to graph this thing, if you were to graph y equals 5x squared minus 8x plus 6, how many times would it cross the x-intercept? Not at all. Okay, let's do a couple more. Determine the nature of the roots of the following ones. Okay, so again, we're just going to use b squared minus 4ac. Now, I should have done one equation where it wasn't perfect like this. Like, just so you're clear, if the question had been 9x squared minus 30x equals negative 25, you understand you would have had to move the 25 over first, right? So to make it 9x squared minus 30x plus 25 equals 0, it must be equal to 0, so you have your a, b, and c value, just like before when you use the quadratic formula. Okay, b squared, well, that'd be negative 30 squared, oh, that's a big number, minus 4 times 9 times 25. Negative 30 squared is 900, minus, well, 4 times 25 is 100, times 9 is 900. Oh, we get 0. So how many solutions? One solution, or one root. One real root. I guess I should start putting real in here. Okay, and the last one, you can probably guess what you're going to get on this one. B squared minus 4ac, b is 5, so 5 squared minus 4 times 3 times negative 2. Oh, I surprised myself. I thought I was going to... Yeah, right. Sorry. 25 minus 4 times 3 is 12, times negative 2 is negative 24. So you get 49. That's a positive number, so you're going to get two real roots. By the way, are they going to be... Is this something you could have factored or no? Yes, you could have factored because it's a perfect square, so it's two real rational roots. And you could have factored, let's make sure that's true, two numbers that multiply to 6 and subtract to 5. Yep, you could have done 6 and 1, and you could have factored that one. Okay, last question. Boy, the setup took a long time, but the actual questions are very, very fast, aren't they? Okay, determine the values of k for which the equation 3x squared minus 5x plus k equals 0 has two real roots. Well, if there's two real roots, what has to be true about b squared minus 4ac? What needs to be true is that amount has to be greater than 0. So all we do is plug in these things and see and solve the inequality. So b is negative 5, so negative 5 squared minus 4 times a, which is 3, times c, which is, oh, what's c? There's nothing there. It just says k. Well, that's fine. That's what we're going to solve for. Is greater than 0. Okay, negative 5 squared is 25, minus 4 times 3 is 12k is greater, it's greater than 0, sorry. Now, what I would do at this point is I'd move the negative 12k over. But you don't have to. And I'm actually going to do it differently here just to remind you of something when you're solving inequalities. So let's say we subtract 25 and subtract 25 here. So you end up with negative, that's still there, negative 12k is greater than negative 25. Okay, what's our next step? Got to get the k by itself. Divide by negative 12 and divide by negative 12. Now, do you remember? You should have some kind of alarm bells going off in your head here. When you divide by a negative or multiply by a negative number and you're dealing with inequalities, what happens? The inequality sign flips around. So it's actually x is less than negative 25 divided by negative 12 is just 25 over 12. That's your answer. Okay, so you have to remember that thing about flipping the sign around if you're dividing by a negative number. Okay, oh, what if this didn't say 2 real roots, it said 1 real root? Well, then you'd make this greater than sign just an equal sign, and so you'd end up with all the same. It'd be k is equal to 25 over 12. What if it didn't say 2 real roots, it said no real roots? Well, then you'd want b squared minus 4ac to be less than 0. Everything would stay the same, except you'd have the sign the other way. It'd be k is greater than 25 over 12. Alright, that's the discriminant. If it seems confusing in any way, don't worry. It's really not that confusing. I just have probably done a poor job explaining. If you understand, yay, good work.